All right, sixth grade. So we're going to have a test on Tuesday. We went over our review today, so just want to make sure that you're understanding. Remember, we talked about subsets. We had whole numbers, which were 0 and the counting numbers. And then we talked about, we had integers, which were going to include the negative numbers. And remember, whole numbers are a subset, so integers are the negative and the positive numbers in 0. And then we had rational numbers, which was anything that could be written as a fraction or a decimal, including integers and whole numbers. So if we look at negative 2 falls in the integer category, but an integer is a subset of a rational. So it is also a rational number. 10.5 is a decimal. That is only rational. 0, however, falls within the whole numbers, which is a subset of integers. So it is also an integer, which is a subset of rational. So if it is a whole number, then it is also an integer. It is also a rational number. Same thing with 9. It is a whole number, so it's an integer, so it's a rational. 5 is just a decimal, so that is only rational. 6 is a fraction, only rational. 7 is a decimal, and it's negative, but the decimal trumps that, so it is just rational. 8 is rational. 9 is rational. Then on your true-false, you kind of wanted to review this chart up here. It says a whole number is always a rational. Well, we had 2 whole numbers. Were they also rational numbers? Yes, a whole number will always be a rational number because it is a subset of rational numbers. An integer is always a whole number. Well, these whole numbers are integers, but negative 2 was an integer, but it was not a whole number, so this is false. It can be an integer and not a whole number. If a number is expressed as a ratio, A over B, which again is just a way to write a fraction, where A and B are both integers, we can't have a 0 on the bottom. It is always rational. If it is a fraction, yes, it is going to be a rational. Then we got into some operations. Find the value of each expression. Remember, we are also using integer rules here. These are different. So we need to subtract. We learned when we add and subtract fractions, we need to have a common denominator. Common denominator here is going to be 16. Remember, if you change the bottom, you have to change the top. So I have 12 16s. Take away from 13 16s is 1 16. My 13 is bigger than my 12, and it's positive. So this is a positive 1 16th. This is just an elementary problem. 7 2/3 plus 6 1/4. You do need a common denominator. It would be 12. So times 3 on the bottom and top times 4 on the bottom and top here. So 8 12 plus 3 12 is 11 12. Remember, we are not adding the denominator. Denominator stays. 7 plus 6 is 13. And 11 12. On the back, okay, these were the same, so we need to add and keep the sign. They do not have a common denominator. Common denominator would be 20. Make sure you keep the negative on this second one. So I'm going to say times 4 to get 20, so the top times 4 is an 8. And again, they're the same, so we're adding 7 plus 8 is 15 over 20, and we're keeping that negative sign. Now, 15 over 20 does simplify by 5 to 3/4, and don't forget your negative. Decimals, we said when we do decimals, we need to line them up to do our operation of add, subtract. These are different. So we're going to subtract, so I'm going to put the higher absolute value on the top. And remember, these are different, so we're subtracting 8 minus 5 is 3, 9 minus 7 is 2, 6 minus 2 is 4, and I have more negatives because 6 is bigger than 2, so this is a negative answer. Negative 4 and 23 hundredths. 17, you're going to have to work on the first two and then get an answer, and then the third. So notice these are different. So we're going to subtract them. Your common denominator is going to be 24. So I'm going to say, I'll write them out so you can see how I get to 24. Plus a negative 5/8. So this is times 8. Times 8. This one's going to be times 3 times 3. 2 times 8 is 16. 3 times 5 is 15. And I'm subtracting because they're different. So 16 minus 15 is 1/24. 16 is bigger than 15. And the 16 is a positive. So it's positive 1/24. And then I have to do plus a negative 1/6. And again, these are different. So we're subtracting. So I can write 1/24 plus a negative 1/6. So again, common denominator of 24. So when we look at this, I have a negative 4/24 and a positive 1/24. So we're subtracting a negative 4 and a positive 1. I've run out of room down here. I'm going to write over here. Negative 3/24. And that does simplify by 3 is a negative 1/8. Don't forget your negative. This was a negative 3/24 because 4 is bigger than 1 and we have more negatives. Darla had $452.13 in her checking account. She wrote checks. Guys, remember that is a minus for $53.15 and $117.48. How much is in her account now? You can do this a couple of ways. You can add these two check numbers together and then subtract, which is what I'm going to do. Or you could take this and subtract and get an answer and then subtract. So I'm going to first find out how much she spent. Line up your decimals. 13, 6, 10, 7, 1. And we're going to, this is what she spent, so we're going to take that away from what she had. Be careful when you borrow. Line up your decimals. 0. You got to borrow here. This becomes a 1. 11 minus 6 is 5. 1 minus 0 is 1. We're going to have to borrow here. 15 minus 7 is 8. And 3 minus 1 is 2. So how much does she have? She has $281.50. You do get to use scratch paper on your test on Tuesday, so don't fret. I'm also going to project those integer rules for you. Here we have a double negative becomes a positive. So now this is an elementary problem. 5 and 5/9 plus 8 and 3/5. You need a common denominator. It would be 45 times 9 times 5. So that's 25/45 plus 27/45. That is going to be 52/45. Now that is improper. So we've talked about changing that back to a mixed number. 45 goes into 52 once. Got to borrow here. 1 and 7/45. I'm going to write it over here. And the reason I do that is so that now all of my whole numbers are lined up. So 5 plus 8 plus 1 is 14 and 7/45. It's positive because everything was positive there. 20. These are the same sign. They're both negative, so we're going to add and keep the sign. We need to line up our decimals. And we're adding, so it doesn't matter what number is on the top. So why we use scratch paper and make it nice and neat up kind of everywhere here. 6.39 plus 10.4, put a 0. I know my sign is going to be negative because I'm going to keep it. 9 plus 0 is 9. 3 and 4 is 7. 6 and 0 is 6 and 1. So negative 16.79. Product or quotient. Product means we're multiplying. Quotient means we're dividing. Remember, when we do a product, we're going to do top times top, bottom times bottom. We did talk about Swift swapping our denominators to see if we could reduce first. So that's what I've done here. 5 and over 10 reduces to a negative 1. Don't forget your sign. Over 2. 3 over 9 is 1 over 3. And now I can do my top times top, bottom times bottom. And negative 1 times 1 is a negative 1. And a positive 2 times a positive 3 is 6. When you divide, you need to remember to do keep, change, flip. So I'm going to rewrite this problem. Negative 3/8, don't forget your signs, times, and then we got to do the reciprocal. It stays negative, so but it's 16 over 9 now. Again, I'm going to Swift swap to see if I can simplify before I multiply. So 3 over 9. 3 goes into both of those, so negative 1 and 3. 8 goes into both of these, don't forget the sign. 8 goes into 16 twice. Sorry, my lights just went off. There we go. 8 goes into 8 once. So now I have top times top, bottom times bottom. A negative times a negative is a positive. 3 times 1 is 3. We cannot have mixed numbers. We have to change them, so I'm going to change this to 4 times 1 plus 3 is 7. 4 is divided by 4 times 8 is 32 plus 3, 35. Don't forget the negative. Now I can do keep, change, flip. And again, I'm going to Swift swap to see if I can reduce. 7 and 35 have 7 in common. 7 goes into 7 once. 7 goes into 35 5 times. 8 and 4 have 4 in common. 4 goes into 4 once. 4 goes into a negative 8, negative 2. 1 times a negative 2 is a negative 2. 5 times a positive 1 is 5. And then we have this last one. This is decimal, so we need to divide. Remember, the first one goes in, the second one goes out. Be very cautious here. We have a negative divided by a positive. We know this is going to be a negative. Bring up your decimal. 48 doesn't go into 0. 48 does not go into 24. I'm going to add a 0 here. 48 goes into a 245 times exactly 240. So now I have negative 500 divided by 2. So I can write it. And again, cowboy horse. So now the 2, I'm going to write it over here because I have more space, is going to go outside. Negative divided by, oh, I forgot my negative. Be careful with the signs. See, just that quickly. Negative divided by negative is a positive. 2 does not go into 0. 2 does not go into 0. I brought up my decimal. 2 goes into 5 twice. I'm going to add a 0 here. 2 goes into 10 5 times. So my answer here is decimal 0.